On drone simulations, because it can be quite costly for small companies or those working at the early development stage of your product to do simulations due to the cost or maybe the nature of the simulation itself. So today, what Sahidam will do will be giving us some insight into what are the why simulation is important at the early stage, and also some innovation in drone design and the types of simulations there are out there in the industry. So before that, we would like to run a very quick poll with you, just to ask you if how familiar are you with the topic that we'll be discussing today. In this regard, it's drone simulation. If you have not, I'm not familiar with this, just let us know. And if you are, just let us know also, so we can gauge how the delivery on this should be. And if there is a need for more sessions on this, we'll be happy to do it for you. Just a few more seconds. Do pardon the noise in the background because I am broadcasting from our Buranti in Kuching, and that is a workshop going on outside. So it's so great to be here though. Okay, we have 8 out of 10 of you who have put your insight. With that, I will share these results. I think, Sahidam, you can also see this, right? So I hope this session will be useful for you for the next 60 minutes. We are also now already live on Facebook. I think we will be closing the poll right now. And at the end of it, we will run another poll to see how much you have engaged or gotten out of this session. Yeah. So those on Facebook, please, welcome. If you've joined us before, so happy to have you back. If this is your first time, so happy to have you here again joining us. So if you have any questions for Sahidam, those on Zoom, please put it in the chat. And we will bring these questions to Sahidam at the end of it. And those of you on Facebook, please put it in the comment section so that we can bring it over and put it in the chat with you. The noise is getting a bit more here, so I'm happy to hand this session over to you, Sahidam, for you to take on. Yeah, thank you so much.
Hello, hi, thank you, Roslyn, for the introduction. Hello, guys. Good morning, all. My name is Sahidam Sulaiman. I'm from Hitachi Sunway Information Systems in Berhad. I do hope that you guys can hear my voice clearly before I proceed to my presentation.
Are you guys okay? If you have any problem with the audio, just raise your hands or put it in the chat, yeah? I think we're good to go, Sahidam.
Okay, I am sharing my screen now, and just give me a feedback whether you can see the screen clear or not.
Yes, we are seeing a presentation right now.
Okay, so thank you all for coming into this webinars today. So the topic, I'll be your speaker for today, and the topic will be the fly it before you build it, especially for the drone designs. So we want to see how simulation will benefit in the drone design innovation. Okay, so just a quick webinar information. If you cannot hear me clearly, just type in the chat windows so that someone will give a warnings to me that I need to speak louder or NSS. And then please keep your microphone in mute when not speak. And also, if you have any question, you can type in the chat windows, and then I will spend some time to answer all the questions at the end of the webinar sessions.
I see Victor. Sorry, I see Victor has raised his hand. Sahidam, do you have any questions, issues here, Victor? Or you can put in the chat there.
Hello, hi, Victor. Do you have trouble hearing me speaking, or do you have trouble viewing the slide presentation? Just let us know. If not, I just proceed with the webinars. Okay. And then at the end of the session, after we finish the webinars, we send the link of the feedbacks and also the related materials to you guys. Okay. So basically, here is the agenda that I will try to cover for today. Okay. So I will go into the introduction to this webinar's topic, where they are related to the drone innovations, what are the challenges faced by the drone manufacturers, and then after that I will proceed to the simulation, which is one of the tools that can handle the virtual analysis of your drone design. So I will try to cover a few topics like aerodynamics, acoustic, and also system simulation related to the drone. However, as we know, there are still a lot of types of simulation that can be done, like the structural analysis, dynamics. So if you guys are interested on that topics, maybe we can have another session for that. And then I will proceed with the conclusions to wrap up all the session. Okay, firstly, when we talk about the drones, it's just normal terms that people are calling the drones, but it also known as unmanned aerial vehicles, okay, UAV, or it can be known as unmanned air mobility. Let's say it's used for the transportations and so on, delivery, also known as unmanned aircraft systems, fly boats, multi-copter, quadcopter, and also VTOLs. This is standard terms that representing the drone, which is the actual abbreviation for this is that it's a dynamic remotely operated navigation equipment. So in years 90s, they used this drone for the military purpose, maybe for the research, surveillance, and even for filmmaking. So they use drone to make a film. But starting from 2000s and moving forwards, this drone tried to, the technology already improved, which the drones will be used for the transportation. It's a human transportation like air taxis, passengers, and so on. So in this webinars here, I try to focus on the passengers drone as well as system simulation related to that. Okay. So, but before that, we see how the drone innovates throughout the years. So it can be used for the delivery drones, which already have been long time ago, like the Amazons, they use drone to deliver their products in one day. And of course, it will be useful inside the agricultural industry. Like for pesticide spraying drones, they use this to spray their pesticide to their plant. Okay, and then other types of delivery drones is to deliver the foods, and even they use drone to deliver the medical supplies to urban places. And of course, one of the innovative way of for the drone is that it used for the autonomous search and rescue drones, which is sometimes when you have the earthquake, floods, where the difficult to reach there, you use drone to find the victims so that you can have the rescue teams to go to that location. So, and now the trend is moving towards to the autonomous passenger drones or one-person flying drones vehicles. So this is where the real challenge we are facing right now. How we can validate, how we can check the performance of our passenger drones or even our flying drones. So we try to put into the simulations view how it will help to achieve or to overcome these challenges when designing or validating the performance of the drones. Okay. So as we can see now in the market, okay, this is courtesy of the Porsche Consulting. So we see the trend for these passenger drones, right? Starting in the 2025, the air taxis, okay? We provide the air taxis intra-city and also city to city. And the electric vertical takeoff landings drone in 2035. There will be a few 23,000 units that will be designed, and the market in that time will be 32 billion. So in the future, we can see this kind of trend, like they are trying to produce the passenger drones. So even the certificates will start in 2025. So right now we have to start the design. Okay, so the design should start now, because we need to cater all type of challenges, the problems, and of course we need to meet the certifications. So same things like the road traffic. For the air traffic, you need to have the air control as well. Okay, so this market for the passenger drones will attract a lot of capitals, and then from the proof of concept, we will use the simulation to optimize the design of this drone for the actual operation. Okay, so we see a few challenges that can be faced while we are designing these passenger drones. Of course, this is related to the design itself, where you have the propulsion system. Okay, normally it's produced by electric, and then it's related to the power and energy density. Okay, so let's say if you want to have a more power, you need to have a lightweight of the frames. So this kind of parameters that you need to consider when you designing the drones. Same things happen when related to the thermal or energy management, how innovative your airframes design, and how you want to make sure that the flight operation is fully automated or semi-automated. And then you need to make sure that the design can be accepted by the community in terms of maybe the sound of the drones, whether it can be acceptable by the community. And of course, if these are the passenger drones, you need to make sure that end-to-end passenger experience is comfort. They feel safe when they ride these passenger drones. So these kind of challenges we have to cater before we proceed to fully utilize the drone as a passenger drone. And of course, one of the important thing is how we can verify our design, how we can get verification and also get certification for that. Okay, even we want to fly the drone now, we need to have the drone pilot certification. If not, you have to go to the jail like 5 years. Okay, so how simulation will help to handle this? For that one, we will discuss throughout the webinars. Okay, so here the simulation, as I can see from the poll right now, most of you guys are not really familiar with the simulations. So actually the simulation is the engineering simulation, where we do the simulation for the actual prototype. But this time we use computer power to make all the simulations or the analysis related to the product that we want to design. So I just go a quick overview for this simulation, or the engineering term for this is the computational aided engineering, or CAE. I think most of you are familiar with the CAD, CAM, and the CAE is basically the one of the portfolio for that PLM products or product lifecycle. Okay, so here we can see that it consists either from 1D simulation. Normally it's known as a system simulation. So let's say if you want to have a product to be able to run, you need to make sure the system is completed. Okay, and then by each of the system, they got different domains. So like electronic domain, control domains, mechanics when are related to the structural part, hydraulic system, pneumatic, and also thermals. So this need to be handled by system simulation. And of course, for each of this domain or physics, you can handle it using a separate 3D simulation tools. So nowadays, there are a lot of the simulation tools available around the world, ANSYS, Siemens, Abacus, and so on. So you can list out all the tools here. But the concept is here that every tool has this type of physics that can handle the simulation. Okay, as you can see here, FEM is related to the structural part. MBS is the multi-body dynamics, and also CFD is for fluid dynamics that are related to the flow. Okay. So before we proceed further, let's take a look what is the advantage of the simulations. in the design process. Okay, so traditional way, when we have the design, we need to produce the physical prototypes for that. And then once we create the prototypes, we have to do the testing, whether this prototype can meet the requirements, whether it can meet the requirement and achieve the certification. So let's say we found something, some issues with our prototype, then we need to redesign again. So this process will keep looping until you can get the better designs. So what we can see here that this is costly and also time-consuming design cycles. So this is where the simulation will come into the picture. Okay, instead of you are using physical prototypes, you can use virtual prototypes, which you can study numbers of prototypes, maybe up until 10 or 100 prototypes, just using simulation to find the best prototypes that you can produce. So once you find the best prototypes, you can proceed with the testing and also proceed to build the design. So here the simulation will help you to shorten the design cycles. Okay. So what if you have the tools that can do the design explorations? So this is a standard workflow. You have the workflow for CAE analysis. But if you can see from the bottom workflow here, it's a rapid update, means that you do the design exploration of your study, because we want to be innovates. Okay, we want to have innovation in our design. So we have to be in the front of other competitors, and we want to have produce a new components of the drones. Then we need to be more advanced to them. So these tools will help to find which design can optimize the usage of the drones, which I can cover later. Okay. So let's take a look into the first simulations that I want to share with you guys, which is aerodynamics. So when we talk about aerodynamics, it's related to the flow air that have the flow velocity, the wind, and so on. So it can be internal aerodynamics or external aerodynamics. Okay, so when we focus on our topics today, which is on the drones, the most important component that are related to this aerodynamics is the propulsion system. Okay, so now the new concept of the propulsions, it can be either multicopters or the common drones that we can see nowadays is a quadcopters type of drones. They got 4 rotors. Okay, and then some of the drone concepts. So there are many concepts. If you search Google, you find on the market there's more type of the drones that you can see. So here for these webinars, we try to focus on these multicopters and also quadcopters for the simulations. Okay, so when we talk about the propeller modelings, so if you have a few propeller, only 4, then you need it sometimes to do the simulations. So depend on the numbers of the rotors that you have, this will affect your simulation time. Okay, for example, you can see at the bottom side here, you have around 8 rotors, which means that you need to do the simulation for these 8 rotors into your analysis. Okay, as compared to the 4, maybe you have less information needed to run the analysis. So this type of drones will affect your calculation times. More rotors will affect your solving time, more time to solve the analysis. Okay, so with the helps of the simulation, there are few methods that you can use to study or to model the propeller. For example, in this case, we have boundary element methods that you can see from the animation how the propeller behave, how the propeller rotates. But in actual, these are not modeled physically. You don't have any physical rotors. It's just need you to define how many numbers of rotors, what are the parameters of the rotors, for example, the thickness, the angles of the propellers. And then once you have all the information, you just key in that information into the analysis, or in this case is a CFD analysis. Okay, so it can capture the transient effect of the flows, vortex shading, which is important when you want to deal with the sound from this propeller movement, fuselage loadings, and also how it interact with the aerodynamics. Okay, and then you can also plot the isosurface of this analysis to see the rotor positions in the simulations. So you can see here, basically, it is not the actual rotor. It's not the actual geometry. It's just based on the methods that we are using in the CFD tools to capture all the angles, the thickness, how many blades that you have for that propeller, what is the diameter for the rotors. So from there, you can study what is the best configuration of your design to have this stability when you launch the drone or when you landing. Okay. So these tools will help you to speed up your modelings of the VTOLs with the multiple rotors. So you don't have to worry how many rotors that you want to use for your drones. As long as you use simulations correctly, and then you will gain the results without losing the accuracy of your simulation. So this is one of the important items for the CFD. But not forget about the motion. When we talk about the aerodynamics or the drones, we want to make sure during the takeoff how the drones behave, and then how it transitions from the vertical motion into horizontal motion. And then, of course, you want to know how is the maneuvering system when you start to maneuver your drones. Okay, so this also can be done inside the CFD tools. Okay. So you can see from here the takeoff, the transition from vertical to horizontals, and then the maneuverings in the horizontal. Okay, so if we see in details for the simulation, what you can see that it's like for this one is the vertical takeoff. You can see the velocity, magnitude, the streamline, and then from the results or the contours, you can control what is the configuration or the best configuration that can make the drone stable. Okay, same thing for these maneuverings, you have more controls on the flow around your propellers, so you can optimize your design. Okay, so this is the transition from horizontal to vertical. So when you are talking about simulation, these are related to the meshing, the numbers of elements. Okay, so if you can see here for these 4 numbers of rotors already, you use quite a lot of the elements. So we call it as element. Imagine that if you have 18 rotors like volocopters, they have 18 numbers of rotors. So if you want to simulate it using a standard CFD process, it can take up until a week or even more than that to complete the analysis. So that's why some of the software got the tools that can simplify the methodology in performing the CFD analysis. Okay, so same things, you can see the plot, you can see the contours of the animation. You can also gather the information that you need. For example, here at the bottom right corner here, you can see the thrust information from each of the propeller. So you can do the plot of this thrust, and then you can make sure that you have the optimum thrust to ensure your drone can be take off vertically. So these are the important information that you need from the CFD analysis. Okay, so once you combine everything, for the motion, you can see the takeoff, you can see the transition between verticals and horizontals, and also if you do the maneuverings, you can see how the flow behave around that propellers. So this is one of the post-processing or the visual that you can see from the CFD analysis. Okay. So for the complex motion, it can do the multiple physics because as you can see from previous slide, you have the CFD parts and then you have the motion part. So this is considered as a multi-physics. You can see how the motion affect the flow. you can see how the flow affect the motion. So these are more realistic simulations nowadays, and many software have these tools. Okay, and the most important part when you want to be innovative in the drone design, you need to have this design exploration tools. This will help you to find the best prototype, the best configuration of your drones. For example, in this case, we have different parameters that we want to study. Okay, so for example, we have different rotors parameters, the diameters, the blade numbers, the angles. So using these design explorations, you can find which combination is the best with the minimum thrust or even minimum numbers of blades that you can study from the analysis. Okay, so it depends on how many parameters that you define. It will take time sometimes to solve, but it's worth it if you compare into the traditional way of doing things, which you need to perform or build physical prototypes. Okay, so each of the design parameters that you change, then you need to build the physical prototypes, which is costly. So using these simulation tools, you can study as many designs that you want, and then you can display the results. So once you find the final one or final best design, then you can proceed to produce the physical prototype. Okay, so that is talking about a few parameters. But let's say you want to move further for the better designs. This you can use the design exploration tools. For example, here you can see there are 9 variables for the drones. Like you have this NACA profile thickness, you have the propeller diameter, RPM, the angles, height, and so on. So the tools will help you to find based on the objective that you want to achieve from the simulation. This design exploration will help you to choose the best candidates. Okay, so you can see from the animation here. Okay, so you see different configuration will give different plot. So from there you can study what is the most important parameters that you need to change before you can get the results that you want. Okay, so here are the optimization tools that software have. Okay, so now we are using a star CCM, one of the CFD tools. So basically you can set your goals. Let's say you want to minimize the power for the thrust. Okay, and then you need to make sure that each of the rotors have a minimum thrust. This like the 2500 Newton of the thrust. So using these exploration tools, it will run all the parameters on the backgrounds, and then you can see a lot of the feasible design. So feasible design means that the design that meet all the requirements, and then the unfeasibles is the design that fail a certain criteria. So from here you can choose the best design. So here is design number 88, and then you can do the study on the parallels, coordinates. You can plot the contours. You can plot the cell relative velocity. So this tool will help you to be innovative. You just choose the best design instead of you are producing all the prototypes for each of the design. So here you can see all the variables and which variables that affect most for this thrust. Okay, so this tool will help you to be innovative. Okay, and then the design exploration will save the money, and you can analyze few thousand of the design in one shot. You don't need to make another design to achieve that. Okay, so that will be on the aerodynamics part. As I mentioned, the also important simulation types that the drones need to cover is that the acoustics. So once we mention about acoustic, based on the definition is the study of the compressional wave, which is in the layman terms is related to the sound. Okay, it's related to the sound. So the sound, the sources of the sound can be from the vibration bodies, or even coming from the air turbulence. If you can see from this blade here, the rotation of the part will give the sounds. And then the propagation of that sound may be through the air, it can be through the structures, or it can be mix of both. And then here the receiver is basically the terms, we call it as a microphone, or it's actual our ear, okay, our ear, how we receive the sound from the sources. So in the drone design, the important part is that the noises that coming from the drones need to be within the limits. Okay, so the things that I want to show here is the threshold of the sound. Okay, so if you can see from bottom is the quiet bedrooms, so it's around 20 decibel. Once you go to the rock concert, it's already 120. So this is almost on the pain threshold. Okay, so why is acoustic important into the drone design is that you can control your sound when the drone do the deliveries, or even for the passenger inside the passenger itself, you can know how many decibels that they can take from that. So that's why you need simulation tools to study these acoustics of the drones. Okay, so just a quick information sharings on how the acoustic analysis can be done. You basically need to model the parts, the drone part, and this is the example of the delivery drones. As you can see, the drone itself, and then you have 4 propellers. Okay, so in this case, the propeller is not designed because some of the software, they got the tools to generate the profile of the propellers virtually. So if you can see from the bottom side here is the CFD analysis of the propellers. So we will have, or we will use the results from these propellers, and then we will transfer into the structure part. Okay, so once we have all the information together, then we can do the acoustic analysis. So we can see actually the propeller is rotating, even we didn't have the actual propeller. So this is how the simulation will help you to achieve the design innovation. Let's say you can see from the design itself, you can plot the acoustic pressure, the directivity plot as well. Okay, so in details for this one, I just run quickly for this part here. So you have a pre-processing where you need to define the part itself. So it's the drone, and then you have this big cylinder here. This is for the acoustic areas. Means that you want to have the propagation from the propeller to the location that you want to check or measure. So you need to have this cylinder part here as your acoustic volume. And then of course you need to have the information of the blades. For example, you run the simulations of CFD, or you can get the actual data field from the actual testing. Okay, so once you have that data, you can import into the simulation tools, especially for the acoustic. So you can do the mapping. Basically, the software will convert the pressure from the CFD analysis, and then it will convert into the force data, which can be read by either acoustic, or even you want to make a structural analysis, also possible. Okay, and then the noise load that you can get from the CFD or the actual testing, you can map into the each position. So you didn't have to have the actual propeller, you just need to have that information. Okay, and then once you complete the analysis, you can get this type of results. So just see a quick videos on how we can see the results of the acoustic. Okay, so here every software, they will have the post processing tools where we want to see the plot of the results. So here we have groups of the plane, which is the microphone plane. This is a level that we want to measure. So if you want to measure in a different location, then you need to generate to the another plane. And then here we can put a scaling based on the decibel, and you can play the animation as well to see whether the animation is correct or not. So you have all the results, the decibels, and also you can play around with the post-processing tools to plot how the animation of the products, okay, of the acoustic levels. So for each of these acoustic results or the plot, you can compare with the contour here. So you have this type of rotational around each of the propellers, and then you see the location, how the noise distributed from the sources, and then you want to make sure that each of the location will maintain under the threshold. So this is how simulation will help in designing in terms of acoustic simulation. Okay, so if you want to go further, okay, you can do acoustic or ray acoustic. So this is the example that have been done by Brazil. Okay, they have delivery drones, and then they want to make sure that the sound pressure level affect to the ear levels of the passers-by. Okay, so this can be done as well. And earlier we talked about the passenger drones, right? So we have this information as well. You can plot the acoustic around the passenger itself. Okay, so you can see how the wave propagated or sound propagate from the propeller to the ear of the passengers. So this will help you to decide how you want to control the propeller. What's the design that is best to make the passenger become comfort inside their compartments. Okay. And finally, I try to share with you about the system simulation. Okay. So it's a bit different with the first two simulation that I talked earlier, which is aerodynamics and acoustic. That is more on the 3D type of simulation. Okay. But for the system simulation, it's a 1D types, which is also important when you want to verify your drone design. Okay. Before that, we just understand a bit on what is a system. A system is basically the group of multi-domain or multi-physics. If you can remember, we talk about the domains. We have electrical domain, we have a control domain, we have hydraulics, pneumatics, and thermals. Same thing as a physics, we have a structural dynamics, thermal physics. Okay, so once we have all of this together, it becomes a system. So now, if you can see the simulation tools around the world, how you want to connect that using a 3D simulation, how you want to connect the electrical part into the CFD. That will be a big challenge to the analysts, to the companies. So that's why we have this call as a system simulation to combine all the things together. Just take a look on the hybrid vehicle examples. To produce this hybrid vehicle, you have to have this control system connected to the electrical system. And then you have hydraulics in terms of the absorber. You have a mechanical system. You have a thermal system. So all of this need to be connected to ensure the performance of the hybrid vehicles. Okay. So the combination of this is called as a mechatronics. Mechatronics. If you can see from the graphic here, it consists of the software, mechanics, electronic, and also controls. So the things at the center will be the mechatronics that we want to discuss related to the drones. Okay, so quadcopter drone is the perfect examples of a mechatronic system because it related to the electrical, it's related to the mechanical as well as aerodynamics. Okay, so this is some of the application for the drones, and then what's the effect of the parameters that we define for this drone system to our flight times. What's the stability? What's the max payload that the drones can satisfy when you design this type of drones? Okay, so this is the examples of the drones. You have a control system for the electronic speed controls. You have the controller, electronics and electricals. You have electromagnetics, antenna, the communication between the drones and also the pilot. And also you have mechanical and aerodynamics of the propellers. So it is a system that you need to make sure the system is working perfectly before you launch. Okay. So here are the quadcopter, the physical quadcopter. So once you want to convert into the system, you need to have this type of components. A quadcopter is the moving system. Okay, you have the component for the quadcopter inside the system, and then it moves by propeller. Each of the propeller. So here we have 4 propellers. We need to define 4 propeller for that. Then this propeller is controlled by mechanical and also electrical motors. Okay. So each of these got mechanical part and electrical motors. Imagine that if you want to do this inside the 3D simulation, it is almost impossible. Okay. But it can be achieved by system simulation. And then this is basically done before we have the physical things. Means that we do this system simulation first, and then we get all the results. From here, we decide what is the best parameter for our actual drones. Okay, and then we have electrical power that is controlled by the controllers, and then it will power up by batteries. So this is the connection that we are talking about: multi-domain, multi-physics. You have electricals, you have mechanicals, and then you have a control system that can control this quadcopter. And then we try to focus on the drone itself. What are the information that you need to ensure this system is good, or to validate your drone design? It need to be representative, scalable. You need to have the interface to validate the data, like the plot, the animation, and so on. Okay. So this system simulation will have some tools to get the optimized structures. As you can see here, you have the parameters. For example, you have the drone weight around 1.2 kilos, and then you have this battery size of 12.45 volts with the 3.2 amperes, and also the numbers of motors. So each of these parameters, you want to make sure that the propellers, okay, the propellers and also the motors will give the optimized flight time. Okay, by the default settings here, the flight time of this drone is around 11.5 minutes. Okay, so the software or the system simulation will help you to optimize the flight time by playing around with this value here. And then you have the propeller models, and also you have motor models. So the software will try to find the best combination that can maximize your flight time. In this case, we have this maximized autonomy. And then during the session, so here we are using a sim center MSIM. MSIM is a tools from Siemens. Okay, so once we run the optimization, you can see the parameters of the propellers and also motor is changed. And from here, we can decide what type of propeller models that you need to use. What is the motor models that you need to use to achieve this flight time. Even if you didn't have the motors, but you will still have the information. Okay, you still have the information like the thrust factor, the thrust exponent, the power factor, and also power exponent. Same thing as a motor. You can find the almost similar parameters as to this, so that you can achieve the maximum flight time of your drones. So this is how system simulation will help you in your design process. Okay. And of course, the system simulation, they have all type of post-processing like plotting. Let's say you want to see the current consumption during the flight. You want to see the propeller speed, each of the propeller speed. And even you want to see how the stage of charge of your battery. So this is in the second. So if you run it in the transient or actual time, you can see how the battery drops. And you can estimate for this size of battery, how long the flight of the drones will happen. So it will help you to decide which parameters are the best for your drones. Another examples that I can share with you is this is also prepared or designed by using system simulation for the detect and avoid. So normally it will look like this, the system simulation. You have electronic system or domain, you have control domain, you have mechanical, you have propeller, and then you can input some images for the display. Okay, so how it works is that it's a drone autopilot, how it detect and avoid the obstacle. Okay, so here you can see how we can make animation for that. Once it detect the obstacle at the front, and then it will follow the sphere, and it will move to the next stage, where once it detect the obstacles is next to it, it start to follow the line. Okay, start to follow the lines, and then moving towards the target. This is like your delivery drones. Okay, and once the obstacle is behind, and then we can go to the targets. So this is how you can control using the system simulation to detect the obstacle as well as to avoid the drones to crash into the buildings or anything else, the tree and so on. Okay, so another examples for the flight controls, sensors, and also propulsion system, you can do it inside the 1D simulation to verify, and then to put sensors of the controls. It avoid some of the obstacle by controlling the propeller speed, which propeller that rotate, RPM, and so on. So these kind of things can be done inside a system simulation, which is quite useful when you want to validate your drone design. Okay. Okay, so as a conclusion here, I would say that the simulation is not limited to that one that I'm sharing with you today, like aerodynamic, acoustic, and also system. It can be further than that. You can have like for the structure itself, if you want to have a lightweight structures, then you can perform the optimization, the topology optimization. That's one of the tools to validate. You can have the dynamic analysis of the rotating part. You can have a thermal analysis. Okay, so if you guys are interested on that, maybe we can have another session for that. For this session itself, we have to make sure that we need to go faster and innovate more. We need to become innovative. So we need to use all the benefits from the simulation tools to overcome all the challenges that we have. Okay, and then with this tool, we can become more flexible. If you can remember how the design exploration tools will help you to choose what are the best design for your drone design. And also you can minimize the risk, because this is a totally unmanned. If you are talking about the deliveries, you can minimize the risk of the crash, the comfort, and then you can model all the complexity using the simulation. Not just based on your experience, you use the simulation tools to give you advice. What are the best parameters of your drones? And then you can explore all the possibilities, which is you will become more innovative, and then you will go ahead of your competitors in terms of drones market and so on. Okay. So I think that will be the end of my sessions for today. So if you have any question, I think you can put in the chat windows. And for now, I think I pass to Roslyn for further.
Thank you, Sahidam. Thank you so much. There was a lot of information for me to digest. I think it is also for you too. I'm not sure how many of you here are really drone enthusiasts or working on any project or initiatives on drones or the drone technologies. If you have, just please share it here with us so that we can know what to bring you next. And if you have any what you call that were to maybe request on the type of content that we should bring to you, please also put in the chat so that we can, bring you content that would be beneficial for you. Sada, let me just check through Facebook if there are any questions there. At this moment, there are none, Sahidam. So I guess maybe on your end, if there are any tips or any like maybe issues that you have seen, that challenges that you have seen um, from experienced by drone enthusiasts or engineers or developers of the product developers on this, what are their common um, issues when it comes to simulation or even working with other areas of working on their drone development that
Yeah,
maybe our audience can
sure.
help.
Okay, so let's talk about the general idea of the simulations, not just a focus on the drone. Basically, when we talk about the simulations, normally they will have a big wall between the designer and also the analyst. Okay, so the designer, they just focus on their design to
Yeah,
make maybe the drone design and so on. But once they want to do the analysis, normally they just throw all the things to the analyst, okay, through the wall, over the wall, so that the analyst can do their simulations to check for the structural part, to check for the CFD. And then once they got the feedback, they just throw back into the analysis, the designer, meaning that there will be a big wall that you need to take out that wall so that you will become more innovative, means that the designer is itself or himself, they are not afraid to do the simulation because we have the tools. Because we have the tools, they have the expert from analysts. It's just that they need to improve themselves a bit to study their design, just not the design based on their experience or based on other products. They have to be more innovative. Means that for their design, they need to check what if I, for example, what if I increase the thickness of the drones? What is happened to our weight? What will happen to our structure strength, to the velocity around the propellers? So this kind of thing, when the designer can see the effect of that using the simulation, it will change their mind to design the part. Okay, they don't need to be very in depth into the simulation knowledge, because for the higher levels they can always check with their analyst team. Okay, for them themselves, they just need to find the insight, as you mentioned, they need to find the insight of their modelings, so that once they give to the analyst can focus more in details verification. Okay, so it's not that it's like a teamwork. It's like a teamwork between designer and also analyst. That what I can see from now. There's a lot of users for the designer. They just focus on the design. They're not really into the simulation. But if they have the simulation in their mind, then they will become a better designer with all realistic information that they need to provide to the next levels. So this is it can be done into the any industry, not just drone. It can be automotive, it can be a semiconductors. So this need to be embedded into their mindset. Okay, so that is one of the challenge that I can see for the simulations. And in terms of drone itself, the industries nowadays, yeah, if I can remember, so the drone is widely used for the farmers for the pesticide spraying. So if you can explore all the industries that the drones can help, that might be useful things to developers, the manufacturers, so they can handle every industries, not just focus on the future ones. Like the one that we discussed earlier is more on the future terms, like the passengers drone, that will be on the futures. But the current trends, they have these agriculturals, they have the construction drones. That one we can improvise on that market as well. Okay.
okay, that's a great insight, Saidam, because yeah, I guess when you say it applies to other industries also, it's same like when we're working on a research or R&D. It's not about the research all throughout, but it's about the people who they are doing the research for, right? Their
Yeah,
experience.
yeah, definitely.
Okay, Duki. Well, we do have a little bit more time left. You're just going around. If there's anyone who would like to have one or two last questions with Sahidam, or otherwise, you can just get in touch with us if should you wish to connect with Sahidam or the team after this. Do you have your details that they for them to get in touch with Sahidam or Putri if they need to connect with your team? We can just share it out in the chat in case maybe if they are shy to ask questions here, but if they need to get in touch with either Sahidam or the team at Hitachi for to help them further on this to guide them. So in the meantime, before we go off, let's just run the poll one more time, so that we can you can just let us know how much now that you have understood about drone simulation from this just 1 hour with us. And let's see if we do need to organize further sessions on this and any other topic. I do know, I think the Hitachi is not limited just drone technologies. There are a lot that you have, like previously you shared on something else. So that's great to know. Thank you for letting us know, everyone. Is anyone working on actual drone projects at this moment? Because we do have an area at Varanti that you can utilize for that purpose. Alrighty, that's great to know there's 17 of you here. Okay, if there's none, let me give one last look at Facebook if there's anything there. So I guess I would like to take this opportunity on behalf of Meranti, Sahidam, and Putri and the team at Hitachi. Thank you so much for spending your hour with us today or to share this on drone simulation. And if there any need for us to connect the audience with you, we will do that. And again, we would like very much for you to let us know from the audience, what else do you feel is a need for you for us to bring you the webinars on. And if there's nothing else, we would like to thank you again, Saidam and Putri, for being
Thank
here.
you, Roslyn.
Yeah, you're welcome. You're welcome very much. And it's great to have partners like this in the ecosystem who are always coming forward to share and provide information and knowledge like this to our communities. So we hope to see you again, everyone here. Thank you for making time to join us. And Sadam and Putri, we hope to see you again to connect. We will be in touch with you constantly if there are any more opportunities like this in the future. Yeah, all right. So in that and with that, just I would like to wish everyone a very good and safe week ahead and a productive one too. Just remember to take care. Yeah. And do mask up when you go out there in public. Alrighty. So until then, thank you so much and everyone on the back end too for helping us making this session smoothly today. Okay, thank you, Sadam, and thank you, Putri. Thanks, everyone, for making time. We'll see you again next time. Yeah.
Thank you.